All right, so we're going to jump into 5.4 and 5.5 today, graphing square root and cube root functions. So hopefully we'll be able to graph these when we're done with the lesson today. Okay, so what do they look like? So right here is your parent function. Remember, that's your OG, your original graph of your square root functions. So we start right at 0, 0, and it kind of veers off to the side there. Okay, and I'll make a little chart here to kind of show you what we're looking for. So when you have this function here, you see this little piece right here. Everything's got to be greater than or equal to 0. Because remember, we can't have negatives in a square root, otherwise we get imaginary numbers. So if we started with a 0 in our square root, we would have square root of 0, which is just 0. Now, the way to graph these by hand in kind of a fancy way is you want to pick perfect square roots. So if I pick a 1, that's going to be the square root of 1, which would get me a 1 back out. And I want to pick a 4 for my next number. That would be the square root of 4, which gets me a 2 back out. And hopefully you kind of see the way we're going with this. So let's pick a 9, because the square root of 9 is 3. And then let's pick a 16, because the square root of 16 is 4. And if we graph those, 1, 1's there. 4, 2 is about there, okay? And then 9, 3, we would have kind of out here. It starts to flatten off as we get further out, okay? It'll look a little bit nicer when we get a graph to use. So you want to highlight these because we're going to try to get these perfect squares on each of our graphs. Okay, it's important if we're doing this by hand, you use perfect squares. You can use a calculator, but you're going to get some ugly decimals, so it's a lot nicer to graph with the perfect squares. Okay, well, let's look at domain and range before we actually try one of these. So the domain, x is greater than or equal to 0, like we just said. And then my range is also greater than or equal to 0. Okay, so to kind of highlight this point right here, there's a definite starting point to these things. And then they're either going to go up or down, depending on if it's positive or negative outside the radical. And then they're going to go to the right most of the time. Okay? So let's look at how we graph one of these. Okay? So identify the domain and range of this function, and then use the graph of the function to help determine the domain and range. Okay? So remember, we want to get these perfect square roots. And square root of 16 is probably good enough to go to. Okay? So the trick here is try to figure out what numbers we can plug in to the function here, what numbers we can plug into there to get our perfect squares. Okay, so let's kind of throw this off to the side. If I have an x minus 2, what number would I plug in there to get a 0? Okay, and what number can I plug in there to get that one? Well, if I just plug a 2 in there, 2 minus 2 is the square root of 0, which is a 0. What number can I plug in to get this square root of 1? If I plug a 3 in there, that gets me square root of 1, like I have listed off to the side, which is just 1. Okay? So you kind of have to think about what number we're going to put in here to get these perfect squares. So what do I want to plug in there to get a 4? If I plug in a 6, 6 minus 2 is the square root of 4. Square root of 4 is a 2. Okay? And I'm just writing these square roots off to the side, so I'm reiterating what I'm talking about here. Our chart right here is going to be what we're left with in the end, and that's what we're going to use to graph. So what can I put in here to get the square root of 9? That would be an 11. If I plug in 11, I get that square root of 9, which is a 3. And then what can I plug in there to get 16? Well, I can use an 18. 18 minus 2 is 16. Square root of 16 is 4. So now I'm using this right here to graph the function. So we start at 2, 0, right there. And then we go to 3, 1, right there. 6, 2, 11. So we're off the graph a little bit. 11, 3. And that's probably good enough to draw the graph. Okay. So right there is our graph. Okay. So I want to highlight this part right here again, because remember, we need to plug in things to that function to keep it positive. So if you wanted to, you could start by doing this, okay, setting that greater than or equal to 0. So what numbers would I plug in there that would keep me greater than or equal to 0? Well, it's a 2, so x has got to be greater than or equal to 2. Okay, so then I can go to that point right there, which I get out a 0. So our y is going to be greater than or equal to 0 for this point. So this is our domain right here. And this is our range right here. Okay, that might have been a little bit more complicated than what you want to think about. Generally, you can go from this first coordinate here. Okay, my first coordinate is 2, 0. So from 2, 0, my graph is going to the right. So that's x is greater than or equal to 2, and it's going up. That's y is greater than or equal to 0. Okay, so that's another way to think about your domain and range. All righty. So let's check out another one. So for this one here, we're just looking to identify the domain and range. We don't have to graph it. Okay, we're just looking to identify the domain and range by looking at it. So remember, we need to get this part right here to be greater than or equal to 0. Okay, so we can actually set the entire thing like that, greater than or equal to 0, and solve. Okay, and that'll get us our first point, which might be more complicated than what you want to do. Okay, look here. What numbers can I plug in here to get a 0? Okay, you should be thinking -4. All right, if I plug in a -4 right there, -4 plus 4 is going to get me a 0. So x is got to be greater than or equal to -4. Okay, and then if I plugged in the -4, okay, now let's think about that. Let's get this stuff out of the way. If I actually plugged in that -4 right there, you'd have something like this. All right, so that's a 0, so 3 square root 0. That's just a 0. So y has got to be greater than or equal to 0. So that's our domain, and that's our range. So it's pretty much, you're just looking for what the first coordinate would be. If I graph this equation right here, my first coordinate would be -4, 0, and then it would go up like that from -4, 0. Okay? So all of these functions follow transformations. Now you don't need to necessarily memorize all the transformations and how to do this stuff. It is beneficial for having a good idea of what the graph looks like. And you should recognize these variables. Okay, we've used those before in all of our different transformations that we've worked with. So A, that's going to be our dilation and reflection. H, that's going to be translation left or right. And then K, that's going to be our translation up and down. And you should have these in your notes. Okay, so if I'm thinking transformations by looking at this one, well, I have a number here, here, and here. This is my A, this is my H, and that's my K. If we think about the vertex form stuff we've done before, this is going to dilate, this is going to shift left and right, this is going to shift me up and down. So we can get the dilation when we get our XY chart, but if we're looking at this part right here, remember we kind of always think opposite of the stuff in the parentheses. So that's going to be like a 4, and then we think the same as this one out here, so that's going to be a 2. Okay, so our first coordinate would be 4, 2 right there. All right, and then we can start with an XY chart. So I'm just going to do an XY chart a little bit differently than we did before, so we can kind of see a little bit more work. All right, so X here, function goes here, and then Y here. And again, think about those perfect squares. So 0, 1, 4, 9, and 16 if we need it. Okay. So I'm going to start by identifying X values and then show the work to get all the values for the Y. Okay. So what number can we plug in to get a 0? Well, that would be a 4. If I put a 4 in for that X, that would get me a 0. And then let's keep going with the other ones. So if I plug in a 5, that's going to get me a 1. If I plug in an 8, that'll get me a 4, if I plug in a 13, that'll get me a 9. And we're kind of getting a little bit too big here, but let's just, since I wrote it there, we'll do that 16. If I plug in a 20 to this x over in this function, I'll get a 16. Okay, so I know for each one of these that I'm going to get these perfect squares. So if I plugged in the 4, I'm going to get square root of 0. Okay, and then I just go through the process. So 3 times square root of 0 is 0, plus 2 is a 2. And then the next one, 3 times the square root of 1 is plus 2. So 3 times square root of 1 is 3, plus 2 is 5. 3 square root 4 plus 2, so that's a 6 plus 2 is an 8. And then 3 plus square root, or 3 times square root 9 plus 2, so that's a 9 plus 2, that's an 11. And just to do the last one, because we have it here, 3 square root 16 plus 2, that's going to be a 12 plus 2, which is a 14. Okay, so let's get rid of this stuff right here and graph our coordinates. So we have 4, 2, which is what we thought, that point right there. And then we have 5, 5, so right here, 8, 8, right there, 13, 11, so 10, 11, 12, 13. We're kind of off the graph. 11 is going to be up there, so we'll just graph what we can. Okay? Then let's state domain and range. So we're going right from here and up from here. So domain, x is greater than or equal to 4. Range, y is greater than or equal to, what y value does that line up with? Right here and going up, so y is greater than or equal to 2, which lines up with your first point. Okay? So that is the general idea how you graph these. So I want you to try to graph the next one using the same system. Okay, so if you need to, pause the video, give it a shot, and then come back to the video and see how it's done. All right, if I'm thinking transformations here, I see a negative. That means it's probably going to go down somehow. I see the x plus 5, which I have to think negative 5, and then I see the negative 6. So my first point is going to be negative 5, negative 6, which is right here. Okay? And we said it's going to go down, but let's do an XY chart to be sure. Okay? And I'm not going to do the big one like I did before. Okay, if you wanted to, that's fine. But I'm going to throw the perfect squares off to the side so we can see them. Okay? And we'll stop with 9 just to see if we need to go further from there. We've been going to 16, but we'll see if this works. Okay? So what can I plug in there to get a 0? Negative 5. What can I plug in there to get a 1? That would be, okay, this is kind of goofy. I would plug in a negative 4. Negative 4 plus 5 is a 1. What would I plug in there to get a 4? Well, I got to do 5 minus 1, so that's a negative 1. And then a 9, I would plug in a 4. Okay? So I'll just do the work for the first one here. So negative square root negative 5 plus 5 minus 6. That's a 0. So negative 0 doesn't do anything. We got a negative 6. Okay? The next one, negative 4 plus 5 is 1. So we'll have negative square root 1 minus 6, which is negative 7. The next one we said is going to give us our square root 4. So we have negative square root 4 minus 6. So that's negative 2 minus 6, negative 8. And then the last one we said would give us a square root 9. So we have negative square root 9 minus 6, which is negative 9. And I think that's enough to graph. So we got our negative 5, negative 6, because we figured that's what it was with this transformation. So negative 4, negative 7, right there. Negative 1, negative 8, right there. And 4, negative 9, right there. And this one's going down because we have that negative in front. Okay? So it looks about like that. Not perfect, but it's close. All right, then we need domain and range. So this one, since it's going down, the domain and range is a little bit different. Slightly different, not bad. So Domain, we're still going right from 5, which we can look at this point. Remember, we can just look at that point and get our numbers. So x is greater than or equal to -5. And now y, we're lining up with -6, which is here, but we're going down from -6. So y is less than or equal to -6. Okay? So that negative is going to make our graph go down, which means our range will be less than or equal to. Okay? So let me get rid of this stuff, and that is our graph. All right, so hopefully that makes sense, graphing square root functions. So that's the first part of the lesson. Okay? And for the sake of time, you can skip over this one, but if you would like to, I'll do it here quick. All right, so we want to use this, perfect square roots. And we'll just go to 9 again to see if we need to go any further. So we will plug in a 2 to get the 0, a 3 to get the 1, a 6 to get that 4, and 11 to get that square root 9. Okay? Then the difference between the last one is, remember, we're going to have to multiply by that 3 after we take the square root and then subtract 3. Okay? So 2 times plugging in a 2 there, that gets me the square root of 0. So 3 times 0 is 0 minus 3. We got a -3. The next one, 3 times square root 1 is 3 minus 3. You got a 0. 6 times square root 4. 3 times square root 4. So we're doing this. That's a 4. 3 times square root 4 is 6 minus 3 is 3. And then the last one, 3 times square root 9 would give me a 9 minus 3 is 6. And then graph the coordinates. So 2, -3, 3, 0, 6, 3, and 11, 6. So this one is kind of like that. And domain and range. X is greater than or equal to 2. Y is greater than or equal to -3. And you can get that by looking at the graph, or I think it's easier just to look at that first coordinate, and you'll have it. Okay? So, jumping ahead, if you would like to take a break here, you can pause the video and stand up and take a quick break, and we'll keep rolling. So the next thing we're looking at is a little bit more difficult with these. So we have a big question here that has to deal with physics, all right? So an object is spinning in a circular path of a radius 2 meters with a velocity v in meters per second, the centripetal acceleration a in meters per second. So this is a lot of stuff here, okay? So I think most people have heard about something like this, centripetal force or centripetal acceleration. So here's a real-world application for this. That's things spinning in a circle. And this is the equation that you're looking at. So we're just thinking about how we would graph that function, okay? I'm just going to kind of help you set it up because you're going to see something like that on your homework. And it's the same way as we do it before, but the values inside the square root just need to be a little unique, okay? So I'll scroll way down here so I got some room. So we got v equals square root 2a. And we want to make an xy chart to graph that. We're still doing it the same way. We need square root 0, square root 1, square root 4, square root 9, and maybe that square root 16 with this one. So what numbers are you going to plug in to get those? Well, the first one's pretty easy. We would just plug in a 0 there. Okay, so if I put a 0 in there, I'm going to get that square root of 0. Second one, a little bit more difficult. Okay. What number can I plug in for a to get a 1? Well, 2 times something would get me a 1. That something is a 1/2. If I did 2 times a half, that would get me a 1. Okay? What am I going to plug in there to get a 4? Okay? Well, that one's not too bad. That's just 2, right? 2 times 2 is 4. So the next number is 2. What can I plug in there to get a 9? Well, here's another unique one because 2 doesn't just multiply by something to get a 9 unless you go to fractions. All right? So 9 over 2 is what you're going to multiply by here. And then the last one would be an 8. So if we're working with something like this where there's a number in front of the variable, generally, whatever that number is, your denominator is going to be that number if you want to get those perfect squares. Okay? So let me finish this out here. So this would be a 0, this would be a 1, 2, 3, and 4. And then we would just graph those coordinates. Okay? But the unique ones here are where we get those fractions. So I would look back at this example if you run into something where you're not 100% sure what to plug in to get those square roots when you have something like this. Okay? So this one here, I talked about this in the previous lesson where we have to find an inverse and then graph the function and its inverse on the same graph. So we're going to do this one, and then we're going to do a couple cube root graphs, and then we'll be done. So think about how I do this. How do we find inverses? Well, we invert the variables. Switch the x and y. X on the left, y on the right, and then we're going to have to solve for the variable again. So we have to solve for this y, okay? And we're going to try to get everything away from it. So move the 3 away, and we have x minus 3 on the left, and then we have that. Remember how to undo a square. You got to square root both sides, okay? And then we'll have square root x minus 3 equals y. And now, normally, I tell you guys that you have to have a plus or minus with these, because whenever you use this property here, that square root property, you have to do a plus or minus on both sides. But this one has a restriction. I mentioned that in the last class or the last lesson that you want to use these with restrictions, because if I graph both the positive and negative version of this, it's not going to be a function. So I need everything greater than or equal to 0. That means I can scrap my negative and just graph the positive version of that. Okay? And I'm just going to do a quick freehand sketch of this rather than doing the whole XY chart. And I'm okay if you guys use a graphing calculator to do this one. Go on Desmos.com or a TI-8384. Either one's fine. So graphing x squared plus 3, it's centered at 0, 0, and it's up 3 units. So I'm just graphing this with transformations, okay, because I know that this is going to shift me up 3. Graphing my square root, okay, same idea, use transformations here. That's going to shift me right 3. 1, 2, 3, right here. And then that's going to be kind of off like that. Well, since I followed this restriction with my square root graph, I have to follow that restriction with my square root graph because I don't want the negative version of that. Okay? Then, that is the way the graph looks. This is the inverse. This is the normal one. And since they're inverses, remember, they should be reflections of each other over that y equals x line, which looks like they are pretty good. Okay? So I have my normal function graphed, and I have my inverse function graphed on the same plane, and they follow the rule of inverses. Okay? And if you wanted to, you could write it like this. Okay? So, checking out cube roots now. So, you saw a slide that looked very similar to this earlier. That's because square root and cube root graphs are pretty much the same, except we have to pay attention if we're looking at squares or cubes. So that little 3 there, that number is called the index of the root, of the radical. So this is a cube root. All right? Everything else follows the same thing. A, that's my dilation or reflection. H goes left and right. K goes up and down. Just exactly the same as what we did before. Okay? So I'm going to go quickly out over that back down to here. And you're going to see something that looks like this for a cube root graph. Okay? And this would continue kind of that way. So you can kind of see that this is a point. This has point symmetry. I can kind of pick a point and rotate it. So we want to describe the attributes of the graph. So before I showed you the parent function, now we're going to kind of look at this thing and develop what a parent function might look like, or specifically this graph. So let's look at maybe end behaviors. So on the left, all right, so that x is going to negative infinity. It's over here. My graph is going down. And then on the right, so that's positive infinity. My graph is going over here. My graph's going up. Okay, got that. And behavior's done. So what about domain and range? Well, domain, left and right, the thing covers all values. So that's all real numbers. Range, I'm going up and down. So this continues down over here. Okay, that's just going to keep going forever. And this is going to kind of squeak up ever so slightly, but it's going to go on forever. So domain and range for these are all real numbers. That's a terrible bracket. Okay, domain and range are all real numbers. Then there's one more thing that goes along with this, which is that point right here. And previously we called that our rotational symmetry point. Now here it's called the point of inflection. Okay, inflection. So the point of inflection, that is a -4, 0. And that's where your graph kind of curves to go one direction and switch to the other direction. Okay, so these are the key characteristics, the attributes of a cube root graph. Now let's try to graph one. Okay, so let's graph this one here and then see if we can kind of pick out how these things work. Before we do that, I want to list perfect cubes off to the side. Okay, so let's do like we did before, kind of make an XY chart. And hopefully you think that cube root of 0 might be the first one that pops in your brain. I'm going to write that kind of in the middle of my XY chart because there's certain things with cube roots that you have to remember. So cube root of 0 is a perfect cube. Cube root of 1 is a perfect cube. And then cube root of 8 is a perfect cube. Okay, to get those, it's like what number multiplied by itself 3 times gets you a number. So 1 to the third is 1. 2 to the third is 8. 3 to the third is a 27. Okay, 4 to the third. Hopefully you kind of remember these. That's 64. Okay, hopefully those are ringing a bell. We don't need to go to the 27 or 64 because those are way too big to graph. Okay, so we stick with the nice numbers. All right, now I started at 0 in the middle of my graph or the middle of my chart here for a reason. Because remember, cubes can have negatives and positives and they'll stay the same sign. So we could have cube root of -1. That is a perfect cube. We could also have cube root of -8. Okay, so these right here are the perfect cubes that we want to follow. Okay, stars, exclamation point, smiley, something like that. Put something by those. That way you reference those later on. Those are our perfect cubes that we need to follow. Then it's exactly the same way as we did the square root graphs. You figure out what numbers to put in for x here to get these. Okay? So what number can I put in for x to get a -8? That would be a -7. What can I put in to get a -1? A 0. What can I put in to get a 0? A 1. What can I put in to get a 1? That would be a 2. What can I put in to get an 8? That would be a 9. Okay? And I'll just kind of show you a couple of these off to the side so we can see how this works. Okay, so 0 minus 1. Oops. Gotta do that -7 first. So -7 minus 1 is a -8. So this would be 2 cube root -8 plus 1. Cube root of -8 is a -2. So then you have 2 times -2 plus 1, which would be a -4 plus 1 is a -3. Okay, so that first point would be a -3. We'll get this out of the way. Let's do it for the 0. So 2 cube root 0 minus 1 plus 1. So that's a -1, which the cube root of -1 is still a -1. So we'll have -2 plus 1 is a -1. Okay, and I'll just go and finish the rest of these so we can kind of see what numbers we're going to get. So if we put that 1 in there, so that gets us a 0. 0 plus 1 is 1. Put the 2 in there, that gets us to cube root of 1, which is a 1, which would be 3 when we put it in there. And then cube root of 8 for that last one. So put the 9 in there, get a cube root of 8, which will turn into a 2. 2 times 2 is 4, plus 2 is 5. And then we can go ahead and graph the coordinates. So -7, -3 is my first coordinate. 0, -1, second coordinate. 1, 1 is the next one. 2, 3 is the next one. And the last one is 9, 5. And then we just connect our dots from left to right. So it kind of goes this way, and then it goes to that point right there. And it's going to continue going left, which looks about like the last graph. Okay? So domain and range, and we're not going to do end behaviors on all these. Domain and range is all real numbers for these. Pretty easy. Goes left forever, goes right forever, goes up and down forever also. We got to pay attention to this on some of those because I'll probably ask you what your point of inflection is. Okay? Where does that graph switch directions? Right there. That would be 1, 1. Okay? So that is a cube root graph. We'll try one more of these and then call it a day. Okay? So pause the video, try to graph this one, and then come back to the video and see how it's done. Okay? So let's start off. XY chart. Cube roots. We got cube root -8. Okay, we got cube root -1, cube root 0, cube root 1, cube root 8. Figure out what numbers we're going to use to get those. So first one, -4. Next one will be a 3, then a 4, then a 5, and then a 12. Okay? And an easy way to do these, just like in the last one, if you wanted to show your work, it'd be -3 cube root -8, because we know we're going to get those perfect cube roots because that's why we chose those numbers. Okay? So that's kind of what I was doing in my head before, after I started going a little bit quicker. So cube root of -8 is a -2. So we're going to have 6 plus 5, that's 11. Okay? Next number will be a 3, and then we're going to plug that in, and we get a 2. Okay? So -3 times -1 is a 3 plus 5. Actually, it's not a 2. Will be an 8. Okay, number after that is going to be a 5, and then we're going to have a 2, and then we're going to have a -1. And let's graph those. So -4, 11, we're kind of way up here, and then 3, 8 up there, 4, 5 right there, 5, 2 here, 12, -1. So we're kind of out here. So this one looks a little different when we graph it. It starts from the left and then goes to the right. Let's see if I can connect those. And we are here. Point of inflection is right there in the middle. Okay? It's generally the one that's the same distance from those 2 points in the middle. So that's your point of inflection. Okay? So domain, all real numbers. Range, all real numbers. Point of inflection is a 4, 5. Okay? And then also with the point of inflection, if I look at my XY chart, that's the one that lines up with that cube root of 0. Okay? So that should be in your chart. All right. So that's square root and cube root functions. We're going to save some time and not do this one. And there is your assignment, which should also be located in Canvas if you don't want to take the time to write it down and you want to pop open Canvas. So hopefully you understand how to graph square root and cube root functions. If you need a little bit more help, email me and I can find some more practice for you. Have a good day.